Hello everyone, welcome back to this lecture. In the previous lecture we have discussed about laws of Boolean algebra. So in this lecture I will first revise few of the things and then we will see few more laws. So we have already talked about what is commutative law or commutative property, in which, let's say, if it is written like A and B, it can be written like B and A. So if you swap the input of any AND gate, output or resultant value will be same, right? Similarly with OR gate also, so A or B can be written as B or A. Associative law, if it is written like A or B or C, so we can write it A or B or C, right? Similarly with AND also, so we can associate either B or with C, or we can associate A and B first and then we can operate this, so it will be equivalent only, right? Now distributive law also we have talked. So here we are trying to distribute this AND operator over OR operator. So when we do so, we can write it A and B or A and C, right? But the interesting part here is we can distribute this OR operator over AND also. So when we distribute it, we can write A or B, and here we will write A or C, right? So this is A or C, right? But generally in mathematics, if you compare, let's say this is Boolean algebra. If I talk about the mathematics, this distributive property, let's say if I assume that I'm writing x and I'm multiplying x, rather than x I'm taking some other symbol. So let's say I'm taking small a and I'm multiplying this small a with, let's say, small b, and addition with c, right? So we can write it like a multiplied by b plus a multiplied by c. That's not a problem, like it is we are doing here in the Boolean logic also. But in case if we try to distribute addition over multiplication in mathematics, there's a problem because this operator is having higher precedence. So plus cannot be distributed over multiplication. If you do so, both the things will not be equivalent. So let's say if you write something like this, a plus b, and let's say I write a plus c, this thing will not be correct. So if you want to verify, let's say I'm taking value of a as 2, the value of b is, let's say, 4, and the value of c is, let's say, I'm taking 5. So when you verify it, this value will give you 2 plus 20, so that is 22. This side you will get 22, and here you are getting 2 plus 4, that is 6, and here you are getting 2 plus 5, that is 7. 7 6 are 42. So these two things are not equivalent in mathematics, but if you draw the truth table and try to check the validity of this, it is very much valid. Okay, so please do remember this can also be done. So OR operator is also distributive over AND operator, right? Now we have also talked about the idempotent law, when A and A bar will give you 0. We have also talked about the De Morgan's law. In De Morgan's law, if we are having A or B or C complement, it will give us A complement and B complement and C complement. Similarly with AND operator also. So if there is written like A and B and C complement, then it will give us A complement or B complement or C complement, right? So if there are multiple things, like if there are D, E, F, then the same logic goes for them. Now there's a theorem known as distribution theorem. In this, if there is something written like this, A or B, and with, let's say, A or C, so we can directly write it as A or BC. So how we can write it? If you want to prove it, it is not very difficult, it is easily we can get. So this thing, if you write it like this thing, you can write like A, or in another way, like if you consider this A plus is distributing over B and C. Okay, so if I write it like this, A or, and inside the bracket if I write B and let's say C, if you apply the distributive law, which I have told you in the previous slide here, so this A or operator can distribute over B and C. So same thing when we do here, we can write it like A or B, A or C, right? And the same thing is written here. So this thing can be written as this, and this is the distribution theorem, as we have already talked, right? The next theorem is consensus theorem. So what is consensus theorem actually? When there is a variable A is written, and along with A there is a variable B, and if that variable is available as complemented and with another variable, and if these two Boolean variables are available together like B and C, then this part will become redundant. So we can omit this and we can write AB or A bar C. This is the consensus theorem. If you want to prove it, there are multiple ways to prove it. We can use the truth table. So if you want to go with the help of truth table, you can go and prove it. Otherwise there are other ways also. So in the truth table, let's say if you want to check whether it is valid or not, the same thing you can draw. So let's say I'm drawing the truth table. There are three inputs. I'm considering A, B and C, right? And there'll be 8 rows in this. So there are 3 Boolean variables. So here I'm writing, let's say 0, 0, 0, 0 4 times, and then 4 times 1, 1, 1, 1, 1, 2 times 0, 2 times 1, 2 times 0, 2 times 1. Here we can write 0, 1, 0, 1, 0, 1, 0, 1, right? Now after this, we need to find out, let's say AB. If we want to find out, it is easy to find out is AB. AB, it will give us 0, then it is also 0, it is also 0, this is also 0, and this is also 0, this is also 0, and these two places are 1. Now if we want to calculate BC, easily we can get the BC. So what is BC here? B and C, so it will give us 0, both are 0. This will also give us 0, this is also 0, the third row, the fourth is 1 only, right? Fifth, B and C both are 0, this is sixth is also 0, seventh is also 0, and eighth is 9, right? So we have calculated AB as well as BC. Now we need A bar. So first let's calculate A bar. A bar is the complement of A. So we have 1, 1, 1 0 0 0 0 as the complement of A. Now we can find out A bar C. So if we calculate A bar C, will give us A bar and C. So this is 0 because A bar is 1 and C is 0. Now it is 1 because both are 1. This is 0. This is 1. This is 0. This is 0. This is 0 and 0. Right? Now if you want to calculate the value of like AB, A bar C plus BC. So let's say AB, A bar C, if you want to calculate. AB, A bar C will be AB is here and A bar C is here. We are doing OR operation, so at first place both are 0. It is 0 only. Let me change the pen color. So this is AB and A bar C, both are 0. Here it is 0, it is 1, so it will give us 1. Here it is 0 and it is 0 0. This is 0 and this is 1, will give us 1. This is 0, this is 0, give us 0. Here both are 0, so 0. Here this is 1, this is 0, so it will give us high 1 value. And this is 1 and this is 0, that means it is 1, right? So this is calculated. Now if I want to calculate like A, B or A bar C or BC, let's say. So BC is already, we are already aware about BC. BC is given here, right? And this is already we have calculated. So let's find out. BC is 0 and this is also 0. So the very first place is 0 only. Now we are talking about, let me change the pen color, this value and this value, right? Now this is 1 and this is 0, so it will give us 1 only. Now this is 0 and this is 0, so this is 0. This is 1 and this is 1, it is 1 only. This is 0, this is 0, so 0 only. This is 0, both are 0, so 0 only. 0 and 1 will give us 1 and 1 1 will give us. So if you find out this particular column and this particular column, both are having same value. So ultimately you can say this BC is redundant. If it is there or not there, it is in effect. This is the consensus theorem, right? Now the next is transposition theorem. So what is transposition? Transposition actually you would say if there is A or B is written and there is A bar or C and there is a, let's say, AND operation in between, then what we can write is A along with C and B along with A bar. This is like a transposition kind of thing. So this theorem or the law considered as transposition. So we write A C and let's say A bar B or B A bar, whatever you write. So this is written. If we want to prove it, we can prove it. It is not very difficult. So this can be easily proved. Like we can write this thing as A dot A bar or A bar B or AC or let's say BC. So this thing is 0. So you can write 0 plus A bar B plus AC plus BC, right? So this will give us A bar B plus AC plus BC, and this is again the same theorem which we have seen, the consensus theorem. So this term becomes redundant if there is A and A bar along with two different variables. So similarly there's A and A bar along with B and C, so this B and C is becoming redundant. So directly you can write A bar B plus AC. So that is written here, right? Okay, so although there's no need to prove, you can remember it. This is transposition theorem, right? Now the next is absorption theorem or law. So what is exactly the absorption law? If it is A or A bar and B, then this A bar can be absorbed, and directly we can write A plus B. Now if you want to prove it, how you can prove it? There is one easy way is to construct the truth table, but we can think for another way also. So what we can do is, let's say we start distributing this OR operator over this end. So if we distribute it, how we can write? By applying I'm saying distributive law. Okay, so when you apply this, it will look like A or A bar, right, and A or B, right? So this A or A bar will become 1 ending with A or B. So it is obviously it will give you A or B only. So that is written here, right? So this is very easy to prove. It is not very difficult. The next law is known as adjacency law. In this law, what we do actually, let's say if it is A or B is written along with AND operation with A or B bar, this thing can be written as A only. Or, so this is the first part of adjacency law. There's another part you consider, like if it is A and B or A and B bar, then also we can write it like A. So how we can prove it? If I go for the proof of second one, it is very easy. So I can write this thing like A and B or B bar. So this B or B bar will become 1. So we can write A ending with 1. It will give us A only, right? But if you want to prove this thing, how we can prove it? So you can open it down, or you write it like this: A is this OR operator is distributive, so you can directly write A or B dot B bar. So if you distribute this OR operator over this AND operator, you will get A plus B dot A plus B bar, the same thing, right? So if you are getting like this, you can write A plus, and this will give you 0. So here it is A only, right? So this is the adjacency law, right? Now we can have a number of functions and we can try to minimize it. So in this lecture I have covered few of the laws which were not discussed in the previous class. All these laws will help us to reduce or minimize a function. So let's say if there's a function given something like this, take the example. We take an example problem. Let's say we are having A bar, B bar, C, or BC, or AC, right? So if we want to minimize it, the question is minimize it. Now how we can minimize? with the help of Boolean algebra we can minimize it. So in this, the very one thing, if I try to find out a pattern, there is something common. So this C is common, right? So we can take it as like we write A bar B bar, or B or A, and here I can take like C. Okay, I guess there should not be any problem in this. Now once we have it, after that what we can do, we try to minimize other things. So what we can do here is, if we try to distribute this particular thing here, right? So let's say if I change the color, what I'm writing here is A bar or B, because there's an AND operator, so I'm applying AND. Here I can write B bar or B. Only this thing I'm writing this, or A is as it is, and let's say C is as it is here. So if it is like this, this B bar plus B will become 1. So I can write it like A bar or B, and inside this bracket this is only 1 value, right? Or A and C, right? So this operation, this AND operator will give A bar or B, and this A is there and C, so this will become A bar or A. This will give us 1 only. I hope you are getting. So if I write something like this, because we can commute the thing, we can apply the commutative law. So if I write it like A or A bar plus B and C, this thing will become 1. So I can write this 1 plus B and C, right? And 1 plus anything will give you 1 only. So this will become 1 dot C, and it is only equivalent to C, right? So these were few of the laws and one example. We will solve few examples in the class. Okay, so I'm just closing this lecture. Thank you everyone.